So here is a video on calculating true speed and bearing using vectors. A plane that is traveling at 690 miles per hour on a course with a bearing of 72 degrees is affected by a 120 mile per hour wind blowing towards the southwest at a bearing of 195 degrees. Find the true speed and bearing of the plane. So in order to solve this particular question, what we need to do is we need to find the vector that represents the plane, as well as a vector that represents the wind. In order to do that, I'm going to start by sketching a vector diagram so I can fully understand what is happening here. So a plane is flying at 690 miles per hour. This right here represents the magnitude of the plane vector, and it is flying at a bearing of 72 degrees. What does bearing mean? So bearing is an angle that starts at due north and moves clockwise at that measure. So I'm going to start at north and I'm going to move clockwise 72 degrees. And this right here is going to be the vector that represents the plane. So here's your angle of 72. This vector has a magnitude of 690 miles per hour. Now, in order to find the components of this plane vector, what I need to do is I need to know my angle from standard position. So standard position always goes from your positive x-axis counterclockwise until you hit the vector. So in order to figure out what this angle is, which I'm going to label as theta s for standard position, I'm going to go ahead and take 90 minus 72, which is 18 degrees. And that angle of 18 degrees is what I'm going to use to find my components. So I'm going to go ahead and start setting up for my plane vector. And for the plane, to find my horizontal component, I'm going to take my magnitude, which is 690, and I'm going to do cosine of my angle from standard position. And then for my vertical component, I'm going to do 690 with sine of my angle in standard position. So my plane vector has a horizontal component. Plugging it into my calculator, double check to make sure your calculator is in degree mode. Horizontal component is 656.2, and the vertical component, 690 times sine of 18, is 213.2. So that represents the plane. Okay, so let's talk about the wind. So the wind, again, I'm going to go ahead and sketch a vector diagram that represents the wind. So it is flying southwest. I'm going to go ahead and label so I know where southwest is. I'm going to erase this random line that showed up there. It is heading southwest at a bearing of 195 degrees. So it's heading southwest, which puts me in that third quadrant. So I'm going to go ahead and draw my angle in the third quadrant. And this measure is my bearing, which is 195 degrees. Keep in mind the angle measurement that we want to use to find our components are the angles in standard position. So going from here to here. So I need to use a little bit of logic to be able to figure out what this angle measurement is. I'm actually going to find this angle measurement. That way I can figure out the rest of it. So this angle measurement, I'm going to take 180 minus 195, which is 195 minus 180, and that makes this angle 15 degrees. Now what's happening here to get my angle in standard position is I am not going a full 270 degrees. I'm going to use a different color to show you that. So if I went a full 270 degrees, that would take me from my positive x-axis until my negative y-axis. But I'm not quite hitting the 270. I am stopping 15 degrees before that. So my angle in standard position is going to be 270 minus 15, which is 255 degrees. So that's the angle measurement that I am going to use to find the components for the wind. So now I'm going to do the wind. those components, let's see, my magnitude for the wind is 120 miles per hour. So I'm going to do 120 cosine of 255 and 120 sine of 255. And then we can go ahead and find these individual components. So 120 cosine of 255 is negative 31.06. And vertical component, 120 sine of 255 is negative 115.9. Okay, so what is our question even asking for? It is asking for the true speed and the bearing of the plane. And so in order to calculate true speed and bearing, we need to figure out the resultant vector. So what's happening here is your plane is flying, but the wind is kind of working against it. And so the speed of your actual plane is not necessarily 690 miles per hour because the wind is pushing against it. So I want to figure out the resultant vector, which I'm going to label as R. The resultant vector is going to be the plane vector plus the wind vector. So I can go ahead and add these two vectors together. So I'm going to add this one and this one together to get my resultant vector. As I add vectors, I can take my horizontal components and add them together. So 656.2 plus negative 31.06 is 625.14, and then I can take 213.2 plus negative 115.9, and that gives me 97.3. Okay, so this represents the resultant vector. So this is actually what the plane is doing. And again, I'm going to go ahead and sketch a vector diagram. So if you'll notice, both your horizontal and your vertical components are positive, so that puts me in this first quadrant. Okay, so from here to find the true speed comes from taking the magnitude of the resultant vector. So magnitude comes from taking my horizontal component, so that's 625.14, squaring it, plus my vertical component, 97.3, squaring it, and then taking the square root. It comes from that Pythagorean theorem. So my true speed is going to be, let's see, I got to calculate this. So 625.14 squared plus 97.3 squared, and then taking the square root is 632.7 miles per hour. So if you'll notice, this ended up being a little bit slower than what the original speed was of the plane, which was 690 miles per hour. So this is the true speed. Okay, so the other piece we need to find is our bearing. So bearing I want you to think of as a portion of our direction. So I'm going to go ahead and start by finding this reference angle first. So when you have this triangle right here, you have this horizontal component that is the 625.14, and you also have this vertical component that is the 97.3. And if I want to find this reference angle, thinking back to right triangle trigonometry, that means I'm going to be using my opposite and my adjacent, which is tangent. So I'm going to use the inverse tangent since I'm trying to find the measure of an angle. Opposite side is that 97.3. Adjacent side is the 625.14. So this gives me, so inverse tangent of 97.3 divided by 625.14 gives me 8.8 degrees. Keep in mind that this is our reference angle. What we are trying to do is we are trying to find the bearing. And the bearing is an angle that goes from your north, starts from due north, and heads clockwise. So I'm starting here and heading towards the vector. So in order to calculate, I'm going to go ahead and label this as theta b since it's my bearing. So in order to calculate the bearing, I would take 90 minus my reference angle. So I'm going to do 90 degrees minus my reference angle of 8.8. So 90 minus 8.8 is 81.2 degrees. Okay, so just to recap, what did we do? So we found our two individual vectors. We found the plane vector and we found the wind vector. Keep in mind when you're finding these components, you always want to use your angle from standard position, not the bearing angle. Once you have those two vectors, to find the true speed and the bearing, you need to find the resultant vector. The resultant vector comes from adding the two vectors together. So I'm adding the plane vector and the wind vector, and that gives me the resultant vector. True speed comes from finding the magnitude of the resultant vector, which was at 632.7 miles per hour. The bearing comes from finding the direction. So we start by finding the reference angle first, but since bearing is from due north, we would take 90 minus that reference angle to get the actual bearing. All right, so that concludes our video on finding true speed and bearing for this particular example.